Example 1.4. A current and voltage source are connected in parallel with the resistor. Suppose first that the current source is at 3 amps. Calculate the current and power of the resistor. And then in B, we're going to change that current source value to 5 amps and redo the calculation and interpret it. This is a very good example that shows the behavior of current / voltage sources. Okay, so we're going to start off with this one here, and that this one says that the current source starts off at 3 amps. So then the question that we're asking, what is the current / power of the resistor? So here we go. So what I'm going to do here is that I'm going to start off by drawing the circuit here. So I'm going to have a 3 amp, a 15-volt source, and then I'm going to have my resistor that looks like this here. So this is 3 amps, this is 15 volts, and then this is my 5 ohm. And I'm going to say that this here is going to be the current of the 5 ohm right there. So if I start to look at the nodes, here's what I'm seeing. I'm seeing that I have my bottom node, so there's only 2 equipotentials. One is at 0 volts, and the other one is at 15 volts. So all 3 elements, the current, the voltage, and the 5 ohm, have the exact same voltage drop. So let's go look at this thing. So if I look at the current, I5 ohm, you could see here is that it has to be the voltage of the 5 ohm divided by the resistance of the 5 ohm. And in this situation, we get 15 divided by 5. So that gives me a 3 amp current. Now, if I look at the power should be of the 5 ohm. And there's multiple ways of calculating it because it's a passive element. It should be the voltage of the 5 times the current of the 5. So then that's going to be 15 times 3. So it's going to be 45 watts for the power of the 5 ohm. So when I look at these guys, this is what I have. I have this, and I have that. Now what we want to do here is that we want to analyze the circuit a little bit more. So we're going to analyze the circuit by following the current. Okay, so if I follow the circuit here, again, let's draw this out. So here's my 3 amp. I have my 15 volt, and I have my resistor. So now if I connect this all up, I'm looking at this here. So if I follow the current, we could see here that the current is doing what? I have a current coming in like this, and make this a little bit thicker. I have a current coming in like this, and this is 3 amps. I have a second current that's coming through here that's 3 amps. We're led to the conclusion here is that the current going down through the 15-volt source is 0 amps. So the fact that we have a 0 current, we can draw an equivalent circuit. And this is what the equivalent circuit says here, is that I have, again, my 3 amp, and then I have my resistor, and what I'm seeing here is that this source acts as an open. So when I look at my current is flowing through here, but no current goes through to the voltage source. And so we say that the voltage source, so because no current flows through the 15-volt source, it's an open circuit. So this means here is that if I now analyze the power of this thing, you're going to see here is that analyzing, oh gosh, I forgot how to spell analyze for a moment. Analyzing the powers, we could see here is that there's only one active source and there's only one passive source. And that implies that all of the power comes from the 3 amp source, and it all goes to the 5 ohms, which is now 45 watts, where the power of the 15-volt source is equal to 0. So then the question is, what is the role of the 15-volt source? Well, one, it does not supply / absorb any power. So the only thing that it does here is that it fixes the voltage of the 5 ohm resistor so the voltage of the 5 ohm resistor is now fixed by that, and that's what it does. It fixes that resistor, but it does nothing else other than that. So now what we want to do here is that we want to now go to change the voltage, the current source again. So now we're going to set the current source to 5 amps. You know, I should come back and say one more word here before I move on. So what you're seeing here is that the 5 ohm resistor is completely controlled by the 15-volt source. I mean, I kind of said it, but I feel like I need to say it a little bit more clearer. Now let's go to B here. So now we change the current source to 5 amps. Now, so here's what you got to think about here. Because the 15-volt source does not change, then the 5-ohm resistor behavior stays exactly the same. In other words, I know that this 5-ohm has to remain at 3 amps, and I know that the power of this guy has to remain at 45 watts. Nothing about it changes because the 15-volt source, because it's in parallel to it, will not change. So then the question is that I want to now go back and I want to analyze what happens in the circuit. And as usual, we'll follow the current. So let's write it up here. So now if I do the same thing here, again, I have my source. I have my 15-volt source. And then I have my resistor. So now let's write this all up. So what do I see here? What I see here is that I have a current that has now increased and it's producing 5 amps. But because the resistor is fixed, it still has 3 amps running through this 5-ohm resistor. So if I look at this one node right here, we have there's no choice here, but now the current is now 2 amps that flows through this thing here. So what this argument shows here is that the 15-volt source is now passive because the current entering the high and it's going towards the low is now passive. So if I look at the energy-wise, this is what I see here. I see that my active element must equal my passive element, which then tells me here is that this has to be the 5-amp source must now equal the 12 volts plus the 5-ohm. But we now know that there's 2 amps running through this thing. So this means here is that this guy is going to be 15 times 2. And then my resistor is going to be 15 times 3. So when I look at this number here, this tells me that the power supply, the 5-amp power supply now supplies 75 watts of power. Okay. So that means by increasing the current source value, the power produced earlier was 45 watts. Now it's increased to 75 watts. So as an observation here, so if I start to interpret this, this is what I see here, is that increasing the current source value forces the 15-volt source to become passive. So since 0 power for the 12 volt occurred for 3 amps, so what this tells me then is that if I source is equal to 3 amps, that implies that the power of the 15 volt was equal to 0. Now, if I increase this thing, I source equal to 5 amps, this guy now becomes passive. So what this tells me here is that if we decrease the current source, value below 3 amps, the 15 volt source becomes active. So as an example, let's look at this. So suppose I source equals 1 amp. So if it's 1 amp, then that means here is that I look at my current source and it's going to go like this. So I have 1 amp. Now I have 15 volts. And then I have my resistor. So now if I do the same thing as I did before and follow the current, here's what we're going to see. This guy continues to be 3 amps no matter what. This one now has a current of 1 amp. So the only way I could have 1 amp becoming 3 like that is if the source puts out 2 amps. So now when you're looking at this, we could then compare the active versus the passive. And we could now see that we have what? We have the power of the 1 amp. We have now an active 15 volt source. And then the last thing here is that has to be the power dissipated by the 5 ohms.